In this tutorial, we will be discussing Lewis structures of ionic compounds. Alright, in the Lewis theory, a chemical bond involves the sharing of transfer of electrons to attain a stable electron configuration for the bonding atoms. If the electrons are transferred, the bond is an ionic bond. If the electrons are shared, the bond is a covalent bond. That's important to know the difference between the two. With the ionic, one atom completely gives up its electron to another atom. With the covalent, both atoms share the same electron. In either case, the bonding atoms attain a stable electron configuration. A stable configuration usually consists of 8 electrons in the outermost valence shell. This observation leads to the octet rule, meaning 8. In chemical bonding, atoms transfer or share electrons to obtain the outer shell with 8 electrons. The octet rule generally applies to all main group elements except for hydrogen, lithium, and beryllium when they're referring to the main group elements and you're looking at the periodic table. They're referring to the rows that are a little bit taller than the others. So these over here as well. Each of the elements achieve stability when the 2 electrons, a duet, is in the outermost shell. Remember, valence electrons are the ones being shared or given and taken, and they're the ones who determine the reactivity. When metals bond with nonmetals, electrons are transferred from the metal to the nonmetal. The metal becomes a cation and the nonmetal becomes an anion. So, because the metal is losing electrons, it becomes a cation, and that means it's actually becoming more positive. One way, a mnemonic device to remember this, is cats have paws, cations are positive. So they're losing electrons and becoming positive. Anions gain electrons. So therefore they're going to be negative. So cations are positive, anions are negative. The attraction between the cation and the anion results in an ionic compound. In the Lewis theory, we represent this by moving electron dots from the metal to the nonmetal. For example, potassium and chlorine have the Lewis structures for their individual elements of, here's K, it's in the first row so it has 1 dot. Here's chlorine, it's in the 7th row so it has 7 dots. Notice that potassium only has 1 dot here and chlorine has only one orbital here with only 1 dot. All the other ones have duets in them. So therefore, this potassium dot is going to move over and donate itself to the chlorine. Now potassium doesn't have any next to it, while chlorine has 8. When potassium-chlorine bond, potassium transfers its valence electron to chlorine. The transfer of the electron gives chlorine an octet and leaves potassium with an octet in the previous principal shell, which is now the valence shell. If we look over here on the periodic table, once potassium loses that electron, it becomes like argon. So therefore now they have this. Now potassium with missing an electron has the same electron configuration as a noble gas. Once chlorine gains that electron, it too has an electron configuration of a noble gas. The potassium, because it lost an electron, becomes positively charged, while the chlorine, which gained an electron, becomes negatively charged. The positive and negative charge attract one another, forming the compound KCl. The Lewis structure of an anion is usually written within brackets with the charge on the upper right-hand corner outside the brackets. The charges are shown, but the brackets are not shown in the homework drawing program online. So the brackets encompass the electrons. Since potassium doesn't have any electrons around it anymore, it doesn't have anything to encompass. It's just written on the outside. Alright, so drawing the Lewis structures of magnesium oxygen by drawing two dots. So here's magnesium on the periodic table. It's in row 2. So it has two dots around the symbol for magnesium. If we look at oxygen, 1, 2, 3, 4, 5, 6. It's in the 6th row. So it's going to have 6 dots. Remember, do it once around, and then you go around and you pair it up. And that's how they got 2 with duets and 2 without. So oxygen has 6 dots around the symbol. In magnesium oxide, magnesium loses its 2 valence electrons, which are right here and here, resulting in a positive 2 charge. So once these 2 electrons leave, it now has Mg2+. And oxygen then gains those 2 electrons. Once those electrons are gained, it has a negative 2 charge and an octet. Consider the ionic compound formed between sodium and sulfur. The Lewis structures of sodium and sulfur are, if we look at the periodic table again, here's sodium, it's in the 1st row, and here's sulfur, it's again in the 6th row. So therefore sodium is going to have 1 dot, while sulfur has 6. Two of them are unpaired electrons, while 4 of them are paired up. Sodium must lose 1 valence electron to obtain an octet in the previous principal shell, while sulfur must gain 2 electrons to obtain an octet. The compound that forms between sodium and sulfur requires 2 of the sodium atoms, not just 1, to every 1 sulfur atom. So this electron gets donated to sulfur. So here you go there. Then we have to add another one here to donate it to the other sulfur electron. And that's why we need 2 sodiums when we did the crisscross. Na+, you may remember doing this. Crisscross it to be Na2S. And so the correct formula is Na2S because of those differences in sharing the electrons and trading the electrons. Alright, so let's try a couple. Beryllium and fluorine. Beryllium is right here. It's in the 2nd row. So therefore it has 2 dots. And fluorine is right here. 1, 2, 3, 4, 5, 6, 7. It's in the 7th row. So fluorine has 7 dots. Let's rewrite that. F, 1, 2, 3, 4. Then I start pairing up. 2, 5, 6, 7. Alright, so we notice by the equation, when we balance out the charges, we need 2 fluorines and 1 beryllium. If we look here at the electrons, 1 electron is donated to that fluorine. But we still, so we have Be with F with 8 dots around it now, with a negative 1 charge. We still have another dot here that we need to get rid of. Well, that's why we have to do it with another fluorine. Here's our 7 electrons. That is written pretty poorly. We'll do it again. Alright, there's our 7 electrons. If this beryllium gives up its other electron to the other fluorine, then that means this one will also have a full octet, which leaves beryllium with a +2. 2 plus charge. Alright, so let's do that again. Lithium is here. It's in the first row, so it has 1 dot. Oxygen is here. 1, 2, 3, 4, 5, 6. So it's going to have 6 dots. 2, 3, 4, 5, 6. 1 lithium gives up its electron to the oxygen. We still have an unpaired electron down here for oxygen, so therefore we're going to need another lithium with 1 dot to donate its electron to oxygen, which is why we have 2 lithiums here. So therefore, let's put oxygen in the middle this time. Now that lithium's donated its electrons, it has a full octet, but it has a -2 charge. Then lithium comes around after donating its electron, and it has a +1 now. And that's how you do Lewis dot structures of ionic compounds.